data structures that are in the image format that are dealt with by the system are aligned. We make an attempt to make sure that
what do you mean by natural boundary?
Yeah, natural to what?
bytes are on bytes in the file. If you look at the file, it's a view of mapping that directly onto a piece of memory that's, say, a page line, that every piece of data in that file will be, that's metadata to the image, will be naturally aligned.
Naturally to what?
To its own address.
Right.
It's zero mod, whatever the address size, or the data size is. Bytes are on bytes can be at byte offsets. 16-bit words can be at 16-bit offsets in the file. 32-bit things can have to be 0 mod 4. You don't have to copy things into one structure so you can access them.
Okay, I thought for a moment you might be talking about something else which had to do with image layout versus some sort of page size issue.
Well, that's later.
Okay, put it on the stack and we can get to it later.
Let me go down the list here. Actually, the image format, as it's laid out in the file, is such that it's on the file system allocation boundaries, and the image header does say what it thinks the page size is, right? So there is a question about how big, what you end up with is you have a section, and it's so big, and the end of that section may be longer or shorter on some machines depending on what the residual part of the page size is. Now, one of the things we're going to do probably to make sure this all works real portably is we're actually going to try to get the system to run with a page size different than 4K bytes.
An issue I've seen in practice is that you have two sections that are butted.
We don't do that.
Okay.
That's gone. They're separated and they're on the disk allocation boundary.
Even if they're on the disk allocation boundary, you can still get into problems if the empty space between is too small.
No, because we don't do that.
Okay, as long as you're trying to put in large separations.
We know that the rest of that section is 0 if you page it in. We know where that ends. The pager knows how to page in partial pages.
Mm-hmm.
Is what you're talking about. Yes, sir.
We're talking partly about that and partly about the illness that sticks in my head is, without naming names, somebody came up with a executable format in which they wanted to make sure that dereferencing 0 blew up. And so the first 2K was defined to be not accessible, and your text started at 2K, which worked real fine until you had a system with a 4K or 8K page size.
Okay, I could back up a little bit. In general, we don't map. By default, we do not allow an image to be at 0. And in fact, the lowest we would like to put an image is 64K because of protection boundary problems, right? With pages.
Mm-hmm.
However, you can absolutely use the pages starting at 0 if you want to, because you might want to build an emulation system that has to run programs that did start at 0, like x86 programs, right? Where you really want to start at 0, 16-bit programs. You don't want to access things at 0. So in that case, but by default, we don't do that. The image format is such that we try to minimize and localize any fix-ups we have to do, for instance, for DLL loading. We support resources with the same capabilities as OS2. Let me explain what resources are. Resources are sort of things that you can stick in an executable that can be selected with a call to some library routines by an index or an ID. So typically what people put in as resources is things like they might put a certain font in. You might have a font selection in the image where you can select different fonts for whatever it does, and it would then select that stuff out of the image based upon a key It might be a program that's been internationalized, and you've actually replaced the resource with whatever the messages that it wants to put out. It might be the bitmap of the icon that this thing displays, where this is customizable by a user using some kind of a edit facility that says, well, geez, when I run my favorite program, I don't like the icon that it puts up. I want to put up a different icon. So there's a way to paste those in. The only thing that occurs in the privilege mode of execution as far as activating an image or mapping it is that we map the header, we look at the header and examine it to see that it looks like an image, and then we use the information that's in the header to map the whole file to the address space, and that's all we do in privilege mode. So it's more or less of a map file, right? Which means, by the way, when we map it, we take care of all these things about having partial pages. So we know about all those things. And then when we actually start running the image, in user mode is where we do all the binding and all the fix-up. All right, so that's just done in the normal. We don't have to screw around in privilege mode doing that stuff. The entire image is mapped. The header's mapped, the code's mapped, the data's mapped. The fix-ups are mapped. You read the fix-ups, somebody has to read them anyway. The fact that they're there, you just go get them. I talked about the binding being done in user mode. And we actually do binding. The binding, what you have in an image is you have a set of exports and a set of imports. And of course, the binding is satisfying all the exports and imports. And when you do that, you don't want to spend a lot of time looking up strings, so we use a method called hint indexes. And when somebody binds to something, when you link something, you actually say, here's what's going to be in it. It resolves all that stuff. It keeps a hint. And if the hint index works, fine. If it doesn't work, then we'll go to a string lookup. But basically, you don't have to keep things in sync with respect to, I reference index 5 in that image. You actually can go replace the DLL with another one where it became 6, and it will still work. It will just take a little longer. The DLLs that we provide with the system, which you could think of as being things like the C runtime library and some of the other things, we tend to lay them out in memory so they're mapped at a preferred address, which means that we want to map that thing there if we can. If we can't, then we will have to relocate that DLL dynamically somewhere else, and we can do that too. But for the fastest activation, you want to sort of stay out of the way of where the DLLs are. This is really sort of an extension of cough, cleaning up some things. It's more of a cough-like structure than it is some of the stuff that was in the PC. The PC executables weren't very directly mappable as files, so you could map them into the address space and directly page from it. So that's kind of wraps up what I have to talk about. The next guy to talk is Mark Lukowski, and he's going to talk about the Win32 base APIs. Do the slide, okay?
Yeah, if you give them to her, Madeline do it.
All right. This is the